Okay, integrated science students, this video I posted on the 27th of April. In your weekly document, I wrote on there that you need to watch this video as soon as possible. The quizzes that go along that I'm going to be posting this week are based off of the notes off this video. So if you don't watch the video, the quizzes aren't going to make a whole lot of sense. I asked you guys to watch the video that I posted on how to do the research, the 18 volcanoes that I had chosen for you to do research. And some of you didn't watch the video, even though I said this video explains how to do it. A lot of silly little mistakes were made. Many times I mentioned in the video that I only wanted the name of the country of where the volcano is at. And many of you guys put Alaska, Hawaii for the country when it really kind of should have been the United States. Some of you for certsy said it's just in the Atlantic Ocean, but you didn't kind of go a little bit further to, find out what country. But anyway, I don't make these videos for my health. I don't make these videos so I can just look cool because I'm cool. So I'm doing this for you guys. So when I post a video, watch the video. What you're going to have to do with this is, on a sheet of paper, you're going to write the word volcano notes. And you're going to take the notes as I present them on this video from the slides. It's not like we've done when we were in class where I gave you a nice little skeleton set of notes, the note packets that you filled in. You guys are going to have to take notes like big boys and girls and write down everything that you need to write down. I suggest you pause it so that you can get caught up, because I'm going to be talking pretty rapidly so I can get this over with, because I hate filming myself. So the first thing I'm going to do is I'm going to share my screen and pull this. Sometimes the Wi-Fi is a little bit slow, so as I'm trying to pull up or change screens, it gets a little bit slow. But as you can see, this set of notes is on volcanoes. And I'm going to, remember you guys voted for this, so if you end up not liking it, I didn't vote for it, you guys did. Let's first talk about the types of eruptions. Before we do that, we need to know what a volcano is. A volcano is an area of the Earth's surface where magma and volcanic gases escape. They're going to escape through a vent or a fissure. What type of hole they escape through has something to do with the type of flow, as well as the magma is going to determine the type of flow as well. These gases and magma can escape one of two ways. There's only two ways that they escape: explosively or non-explosively. I remember writing quizzes that specifically ask that question, so I hope you guys are watching this and you get that right. First type is explosively. Let me give you the facts for explosive eruptions, and then we'll go back and watch little videos, just a little clip on what an explosive eruption looks like. You've seen them before because they're the ones that make all the news footage, because they're super cool and exciting. Clouds of hot debris, ash, and gas rapidly shoot out of a vent. That's the definition of an explosive volcanic eruption. Molten rock is blown into particles that harden into the air. It then becomes what we call pyroclastic material, which is something we're going to cover more in depth later on. And this is not, you don't get lava flows. You don't get a whole bunch of molten rock coming out and hardening as rock. You're going to get pyroclastic material. Notice that it says it shoots out of a vent. Make sure you understand that that's the only thing that it can, that an explosive one escapes out of is a vent. It doesn't escape through a fissure. So let's watch just this little Papua New Guinea footage here.
A volcanic eruption in Papua New Guinea Friday sent smoke and ash spewing high over the South Pacific island nation, leading some aircraft to alter their flight paths. Mount Terravur on East New Britain Island erupted hours before dawn. A bulletin from the Raval Volcanological Observatory said the volcano destroyed the town of Rabaul when it erupted simultaneously with nearby Mount Vulcan in 1994. It rumbled to life early in the morning on the tip of the remote island of New Britain.
Now, what I hoped you noticed in that video, they're a really long ways away from that shooting the footage because you don't stand right up next to that and film it. Also, that huge cloud, that's that pyroclastic material that we're talking about. You can see the red hot stuff going a fair bit above the vent of the volcano. That's because there was a lot of pressure putting that out. There's also the type of lava that has a play into what type of eruption it is. So gases and magma can escape explosively, and it will always come from a single vent. It doesn't come from a fissure. I mentioned that. Next one, non-explosively. Again, I'll give you the facts that I hope you're writing down, because if I put a little bullet by something, I thought it was important enough to have its own little dot now, didn't I? This is the most common type. This is a year or so ago when Hawaii was having all the trouble. Tourists were leaving and then other tourists were not coming and canceling flights and not going there because there was some pretty significant volcanic activity. It wasn't the explosive type. It was lava encroaching on people's houses and cities. And it happens a lot there because all of the islands of Hawaii are there because they're shield volcanoes that came from, for the most part, non-explosive lava flows that built the islands. It's a little bit different situation than, most of the volcanoes that we're studying are the result of interaction between tectonic plates. This is actually the plate traveling over a hot spot. But you'll see, this is all the footage you see in Hawaii. They're relatively calm. They can produce a huge amount of lava, huge amount. The seafloor and large portions of the Northwest are covered with these types of flows, these non-explosive. Now, the seafloor is a huge, it's two tectonic plates diverging, splitting apart. As they do, they leave a huge crack in the ocean floor where magma can come up from below and reach the surface, and that is called sea floor spreading. Remember, you guys didn't want to do plate tectonics, and so plate tectonics would have covered that. But anyway, and then the Northwest, if you look at a map of Idaho, a geographical map, and you see, you can see the mountain range and stuff right in the middle. There's where the broadest part of Idaho is. There's this huge thing that kind of dips down. It looks like a smile. They actually call it the Idaho Smile. And that's the result of relatively non-explosive lava flows coming from fissures, which are huge cracks in the Earth's surface, not a vent. You can have non-explosive flows from a vent. That's what's going on in Hawaii. But they're coming from fissures. Also, the Columbia Basin in Washington is a similar type of a geologic phenomena. This lava, when it weathers over thousands and thousands and thousands of years and becomes soil, in the Idaho area, the soil is absolutely perfect for growing potatoes. It's a sandy loam, and that's the result of this lava weathering into soil. And a lot of people don't know this, but there's a lot of potatoes grown in Washington in the Columbia Basin, and same reason, same type of soil. We're more famous for it though. And then these can come from vents or fissures. Some main things that I want you to know on this: explosive can only come from vents. Non-explosive can come from vents and fissures. And know some areas where these types of explosions are happening or have happened. Let's go on to our next phase, our next page. We're going to break down magma. You need to know that magma, it's just molten rock. It's rock that has been melted. The center of the Earth is extremely hot. It's hot enough to melt rock. I will tell you that magma melts, or rock melts, at between 700 and 1500 degrees Celsius. That's Fahrenheit wise, since we're not the metric system people, about 1650 degrees Fahrenheit to 2700 degrees Fahrenheit. Very, very hot. Depending on what type of rock it is, it will melt at different rates, depending on what minerals and metals are in those rocks. Magma and lava are the same thing as far as what makes them up. The difference is where they're located. As soon as magma reaches the surface, it's called lava. It hasn't changed its composition. It hasn't turned into anything else. It's literally magma is under the ground, and when it reaches the surface, we call it lava. It's going to do different things when it reaches the ground. It'll start to cool because it's no longer close enough to its heat source. The composition of magma contributes to how explosive an eruption is. It's not the only thing. We have the pressure in the magma chamber. We have, the size of the hole, whether it's a small vent, a large vent, fissure, whatever. But one factor that determines how explosive an eruption is linked to the magma. And there's three things that magma has that will make it more explosive. Silica. Silica makes magma very viscous. If you don't know what viscous is, I want you to look it up. But it has viscosity. Viscous is the adjective. Viscosity is a noun. It tends, because it's very viscous, it'll plug up vents when it hardens. And that's, it's kind of like when you have a bottle, a plastic bottle, and you put a cork on. If you set the cork on there just a little bit, just tap it a little bit, you won't have to squeeze very hard on the bottle to get that cork to come out. But if you really tamp it in there, tamping that cork in there is like having the vent on a volcano clogged up by very high silica lava. And then it's more difficult for gas bubbles to break open. Think of this: if you have a pot of water on the stove and some spaghetti sauce on the stove in a pan, and you're bringing both of them to a boil. The water comes to a boil and the steam escapes, and you'll get a little bit of water outside the pan, but for the most part, it's not that hard to break the bubbles. The gas bubbles are coming up. It's not that hard to break the water open for the gas to escape. But in tomato sauce, it's much thicker and it's much more viscous. And so you have to get more pressure from the gases rising from the top to break that open. And that's why if you boil the spaghetti sauce, it splatters all over the place. And then your mom gets mad at you. So silica is one of the things that makes lava more likely to be involved in an explosive eruption if the magma has a lot of silica. Also, if the magma has a lot of water trapped. When it's underground, water is compressed as it's heated, and it's wanting to spread out. The water molecules are wanting to spread out because they're getting more kinetic energy, they're moving much faster, and they're wanting to expand like water does. When we take regular water and we heat it and turn it into a gas, those gas particles get farther apart from each other, and the gas phase of water takes up more space than the liquid phase of water. Once it starts, so we've got this water that's compressed, it's still just as hot. If it didn't have that pressure around it, if it didn't have the earth applying pressure to it, it would be escaping into the gas phase. It can't. It's super hot. It's at the temperature where it can escape into the gas phase, but there's not enough room. The earth is holding it in that spot. So when it moves rapidly to the surface, it rushes into the gas phase very, very quickly and creates an explosion. And then the other thing, other than just water, if there's a lot of water in the magma, it can make it more explosive, but also just gases in general. As these rocks are melted, there's different minerals in those rocks and different elements, and they melt and then evaporate or vaporize at different temperatures. And similar to the water, as long as it's underground, they're kept in the liquid phase because of the pressure. But once it reaches the surface and the pressure is released, it goes so rapidly into the gas phase that, again, we have a explosive eruption. It's kind of like when you shake a bottle of pop, you have the gas CO2 is in the bottle of pop. Okay, they put it in there to make it fizzy. And if you don't shake it and open it up, it will slowly release the CO2. But if you shake it up, you're causing those CO2 particles to get more kinetic energy, and they're wanting to get away from each other. And so you shake it up. Then when you take the lid off, they rapidly go into the gas phase, and that's why it fizzes all over the place. So last thing we're going to do, nope, did we do that? Lava by composition. Yeah. Yeah, we got a little bit more to go. So there's three basic types of lava. There's what we call felsic lava, and it's very high in silica. So if it's high in silica, it tends to be, would lend itself to be in a more violent eruption. It's high in aluminum. Al stands for aluminum. Because of this, the silica and the aluminum, it's very viscous. If it's very viscous, it's going to flow very, very slowly. It's going to trap gases. That goes back to the three types of, when we broke down magma, if it has a lot of trapped gases, it tends to be explosive. And when it hardens, it clogs vents. Clogging vents is causing the need to be more pressure from the magma chamber to push it out. So again, felsic lava, high in silica, high in aluminum, makes it very viscous. Felsic lava is going to be in a lava that's oftentimes involved in a very explosive eruption. Then we have this is an example of felsic lava. It's flowing. It's not that the video that I showed you, it was flowing very, very slowly, and it was kind of a ropey surface. This is a little different. This is a different type of lava flow. It's still, but because of the nature, the felsic, the high silica, high aluminum, so forth, it's cracking at the top, and that's kind of an interesting phenomenon we'll get into later. Intermediate lava is lower in silica and aluminum, and it's much less viscous. And so it's not necessarily going to be involved. It could be if there's other factors involved, if the vent is especially small or whatever. When I keep talking about small vents and large vents, think about if you have a certain amount of water that comes out of your faucet when you turn it on. If you put on a hose that's like 5/8 inch, the pressure at the end is you turn the faucet on, you let it come out the end of the 5/8 inch hose, you're going to have a fair amount of pressure. You shut it off, take that hose off, put on a 1/4 inch hose, that pressure is going to be much greater because the same amount of water has to rush out of a smaller area. It's going to have more pressure. Same thing with volcanic vents. A much smaller vent is going to have, it's going to come out with much more pressure. Then we have mafic or mafic. I've heard it said both ways. I really don't care. It's also called basaltic. A lot of this in Idaho, because that's the type of lava that was coming out of those fissures thousands of years ago. It's low in silica. Remember, lower in silica tends to be make it less viscous. It's going to be higher in iron and magnesium. Okay, this is also a much darker. When these solidify into rocks, it's much darker. Iron makes it much darker than aluminum makes it. Here is an example of a mafic flow. You can see going much, much faster because it's much less viscous. So we have talked about lava, magma. What's in it tends to determine how explosive an eruption can be. The composition that makes it up will also have a lot to say with how viscous it'll be and how, oops, I didn't want to do that. We're going to do that one later. That'll be later. The explosiveness of an eruption. So your main thing right now is you need to get this stuff down and get a good set of notes out of this. I hope that you are doing well.